In this course, we will explore various methods to manage the position and layout of visual items, starting with the simplest techniques and progressing to more advanced methods for handling complex and dynamic layouts. This course builds on foundational knowledge, such as language syntax, items, and their fundamental positioning and size properties. In this section, we will start with the Qt Quick module, exploring anchors. We will discuss the benefits and challenges of each method, ensuring you are well equipped to choose the most suitable approach for your application's design and structure. To start off, we will create a simple application that displays a number of images and review one of the ways we can arrange them. First, let's create a new Qt Quick project using the New Project wizard. Select File, New Project. Choose Application, Qt, and then Qt Quick Application. In the Project Location tab, name your project anchors and choose your project's location. We will select Qt 6.5 as the minimum version from the drop-down list if not already selected. This helps the wizard set up the project appropriately. In the Kit Selection tab, choose which Qt version to use for this project. You can select a Qt desktop kit for 6.6 or later. Here we'll choose Qt 6.7 for Mac OS, which will work just fine. We can skip the project management section for now as we are not yet concerned with version control. Click Done, and you should see a brand new project containing a simple Hello World window. A quick build and run will confirm that everything is working so far. Looking at the top of our main.qml file, we see that the Qt Quick module has already been imported. This import provides access to many basic types such as item, rectangle, text, mouse area, and image, which we will use here. Let's make the window bigger than the default size, for example, 1200 by 800, to give us more room. This size can be changed freely at any time, even at runtime by resizing the window. We should also give it a more descriptive title, Hello Anchors. We need some images for building our application. To add them, we'll copy the assets provided in the Git repository for this course into our local project folder. Next, we'll add them to our CMake project using the Add Existing Directory menu option and selecting the Assets folder. This will add the asset references to the QML module's Resources section in the CMake project. Now we are ready to use these resources in our project. We will be repeating the steps of creating a project and copying assets for each of the following sections in this course, so feel free to revisit these instructions whenever needed. With the image assets now added, we can start using them in our project. We have added 10 image files to our project. Let's begin by adding 10 image elements to the main.qml file. First, we'll add one image element, give it the ID image0, and set the image source. Next, copy and paste this image element 9 more times, adjusting the IDs and image sources to match the corresponding images. We should now have 10 image elements. At this point, each image element has a default XY position of 0, 0, so all the images will be stacked on top of each other. Image 0 will be at the bottom, and image 9 will be at the top. Qt Quick's natural Z order means that elements are stacked in the order they are declared in the QML file. The first element declared is at the bottom, and each subsequent element is stacked above the previous. Let's arrange the images in a horizontal line using anchors. We'll bind each image's left anchor to the right anchor of the image to its left, except for the first image, of course. When we run the application, we only see a couple of our images. Why is this? The images are quite large and all different sizes. Using anchors as we have done only affects the position of the image items. Since we haven't handled the size of the images, each image remains at its native size in pixels, extending off the right-hand edge of the window. Wouldn't it be great if we could quickly zoom out in the window to see all the images? We can do that by adjusting the window's contentItem properties. Using the contentItem group property, set the scale to 0.1 and the transform origin to item.topLeft. Running the application again will reveal our 10 images in a line from left to right. Note that adding a scale property to each image will not change its width, height, implicit width, or implicit height. This means it would not impact their positions due to anchoring. Since all the images are parented to the Windows content item, applying a scale to the content item scales all its child images and their positions due to anchoring at the same time. Let's take a step back and consider some pros and cons of using anchors for laying out our components. Anchors are very simple to use, efficient to execute, and versatile for quick and straightforward layouts. They should be your first thought when beginning the design of your layout. They may be all you need. The humble anchors.fill parent will always be your best friend when setting up your item containers. However, one problem with using anchors this way is that each item contains a reference to one or more other items. Think about what would happen if we wanted to modify the number of images in our application. For example, what if we removed image 5 or inserted another image between image 7 and image 8? Or what if we wanted a vertical arrangement? How maintainable is this approach if we plan to grow our app with future changes? It's easy to see that adding and removing items within an anchor chain causes a code maintenance problem. Wouldn't it be great if we could just add our images inside some kind of item that took care of positioning them next to each other so we don't have to set or maintain anchors, and where adding and removing child items has better flexibility? In the next section, we will look at positioners and see how they provide us with a more dynamic approach.